Alright, hello again, welcome back. So today we're going to be discussing going for the 4 for the Pythagorean Theorem unit, which is using the Pythagorean Theorem on 3D shapes. And so we're going to be going over the Pythagorean Theorem on boxes and cubes and also on cones. So after this lesson, you should be able to use the Pythagorean Theorem to find the diagonal of a box and also use it to find slant heights and regular heights of cones. So let's consider the boxes first. So there's a few steps that you have to follow. We're going to begin by drawing a picture and labeling the sides. Then we're going to draw the diagonal going from the upper corner to the lower opposite bottom corner. After that, we have to find the length of the diagonal of the base or the top of the box using the Pythagorean Theorem. And then we have to use the Pythagorean Theorem for a second time with the diagonal of the base you just solved for, and the height to find the length of the diagonal of the box or cube. So let's look at our first example, which is already done out for you. So Lindsay wants to nail a candle that is 8 inches tall to her friend for her birthday. She's at the store looking for a box to shove the candle in. Lindsay needs to know if the candle will fit diagonally in the box shown. How can she use the Pythagorean theorem to help her answer this question? Show your work in the space below. So first, we're going to find the diagonal distance of the base. So what this means is, we're going to take this length of 4 inches, and this length of 3 inches, and then we need to find the length of the diagonal, which is shown by this line here. So you can see that if we just take this base right here, just picture it as just a rectangle. And all we're doing is finding the length of this diagonal, which right here we can form a right angle and use the Pythagorean theorem. So then you can see that we take the length of our two sides and square them, and we consider this side to be A and this side to be B. And then we solve for that C equals 5. So now that tells us that this length is going to be equal to 5 inches. Now, we can use this new length to solve for the length of the diagonal from the lower opposite corner of the upper corner we're going to. So now consider this shape, or this triangle that we get now. And then our right angle is going to be here. So now it's almost like a triangle going through the center of the box diagonally. And then we do the same thing and use the Pythagorean theorem, where now this 5 right here is going to be our A, and then this 7 is going to be our B. So we have 5 and 7, and then they solve for C, which is 8.6. So because the diagonal of the box is 8.6 inches, and the candle is only 8 inches, that tells us that the candle will fit diagonally. And so you'll see now that there's a couple problems for you to try on your own, and try and use the example above to help guide you in doing these two problems, and check your answers in the binder. And now we're going to move on to using the Pythagorean theorem with cones. And there's a few vocabulary terms that you have to know. So the height is just the point that intersects the base in a 90-degree angle. So the height is going to be this line right here. And then we have a slant height, which is exactly what it means. So it's just the height that the cone is slanted at. So our slant height is going to be this line right here. And it's usually shown with an S. The diameter is only from one side of the circle to the opposite side of the circle through the center. So when we're talking about the diameter, we're talking about the entire length of the circle, whereas the radius is only half of the diameter. So the radius can only be from here to here, where the diameter goes all the way across. The steps for cones are very similar, except they're a little bit easier than finding the diagonal of a box. So we still have to draw a picture and label the diagram, And then we're going to draw in a right triangle using the radius, the height, and the slant height, and then use the Pythagorean theorem to solve for the missing side. So here we have a cone whose diameter is 40 feet and the height is 21 feet. So we're trying to find the slant height. So they give us diameter is 40 feet, and remember diameter is the length of the entire circle. So this whole thing is 40 feet. And our regular height is 21 feet. So that's this part right here. It's not the slant height. And now we're trying to find the slant height. So now you guys can see that this part right here forms the right triangle that we're going to use to find the slant height. So first we need to find the length of the radius. Remember that the radius is half of the diameter. So R is going to equal D over 2. And D equals 40 feet. So all we're going to do is substitute in 40 in for D and do 40 divided by 2, which equals 20. So our radius is going to be 20 feet. Now we're going to label our variables and say A equals, B equals, and C equals, like we've been doing. And now this new side we're using is 20 feet, so A is going to equal 20. B, which is our height, because it's on opposite the right angle, is going to be 21 feet. And C is going to be that question mark, because C is representing the slant height because it's opposite the right angle. So now we're going to solve for A squared and B squared. So A squared equals 20 squared, and that equals 400. And B squared equals 21 squared, and that's going to equal 441. Now we can take our formula for A squared plus B squared equals C squared, and substitute in our values for A squared and B squared. So then we're going to get 400 plus 441 equals C squared. Then we can add that 400 and 441 to get 841 equals C squared. And now we're going to take the square root to find the slant height. So the square root of 841 is equal to 29. So 29 equals C. So now we can say the slant height is 29 feet long. And now you guys will see there's another problem for you guys to practice on. So you guys can try that problem independently and then check your answer in the binder or ask Ms. Leary any questions you might have.